class we will be looking into structural design process and starting the process adoption of a structural system. The term structural system is the key word here. Your system might be load bearing structure, framed structure, braced frame, walls with the frame, tubular structure, outriggers. So these are the different structural systems which you will be going through in advanced structural design. So structural system is a key point. For what structure you are applying this. If you are building normal 3-story structure, it is enough for a load bearing, and if you are going beyond that, you need shear walls. So up to ground story plus the 3 floor, you can go for this column oriented type and column and beam. So this type of structural system is called framed structure. So these structure are built by using this frame. What are the frames? Beam and column are the frames. By making number of beams and number of columns, you can rise through your vertical construction. But if you are going beyond 7-story or 8-story, only the beam and column is not sufficient. You need additional structural member. So the shear walls are introduced there. If you are going for too much height of a structure, see your classroom is for a height of 4 meters from your floor to the roof. So if this is the case, the frame is sufficient. If your floor towards the roof is more than 10 meter height, then what happens? You need large opening. The workshop and the industry where you are working, these places will be having much more clear height. That is more than 10 meter or 14 meter, you need braces. What happens? Your structure is supposed to have the lateral force due to wind, and due to that there might be sway. So the lateral deflection is known as sway. So in order to resist that, you are providing the bracings. So if you are going far beyond that, you need shear walls. So shear walls are the construction which is being built in apartment houses. So without any shear wall, there will be no apartments which are practically built. And if you are going beyond that, for 12 floors and up to 30 floors, if you are constructing, you need core walls. So core walls are a different structure which the walls will be constructed by using steel, and it will be concreted after that, and the reinforced concrete walls will be there in the center, and the outer walls will be there as you see everywhere. There are the brick walls. So like that, these are all called structural system. Why the single story structure is being only built by using brick or hollow block? It is sufficient. But if you are going for 3 floor, then frames are mandatory in order to resist the loads. If you are going beyond that, you are changing your structural system. If you are going to construct a football stadium, the stadium might be very big and large, and you need roof for that. There you will be going for different structural system, that is cables and stays. So you can use that and you can construct. Why the beam and column is not available? These are all the different structural systems. So this is the first process, adoption of structural system. What is required? You should choose. This process needs what? First one is knowledge. Second one, experience, intuition. The civil engineer need intuition. Have you heard about this term, intuition? If you need a structural system, if you want to build that, you need intuition, imagination and creativity. So these process will only gain when your experience gains. These part you can take the advice of the structural expert or the senior engineers. So they might have the idea of this. So when you go through all the process, you will gain the first step. Preliminary analysis. Before doing any structure, fix the structural system. Then do the preliminary analysis. What do you mean by that? In the last semester, how many types of technique you have learned for finding shear force and bending moment? Slope deflection method, moment distribution method, Kani's method, matrix flexibility and matrix stiffness. You know 5 technique. What is the use of that? Then why you are studying now is, see, these subject analysis of indeterminate structure will help in preliminary analysis. So if you want to become a designer, designer is a job. If you know to design a structure, it is a job. You will be paid for that. But if you want to become a designer, not only a single subject is enough. You need combination of certain subjects. So if you are strong with the analysis of indeterminate structure, then you can find approximation, estimation of load, general behavior. What do you mean by general behavior is finding shear force and bending moment. If you know any one technique, that is slope deflection or moment distribution, any one technique if is known to you, then it is okay. So go by that, and you can do the preliminary analysis. You will be knowing shear force, bending moment, slope and deflection. Then next thing is proportioning of members and their connection foundation. So this is the next step. Here comes the geotechnical engineer, the person who studies about soil, the person who studies about foundation engineering. He is a different expert. He has to come in the design and he will give you the safe bearing capacity of the soil. What is the water table level? See, one of my clients at the district of Theni are currently constructing a G+3 house. When they excavate up to 5 feet, they found the water table. In 5 feet, they found the water table. That is, if a man is there in a pit, within his height, he is finding the water table. The water rises to the pit. You want to do the foundation. If water is coming at the 5 feet, what you are going to do? Are you going to construct there? Are you going to put your foundation? Is it okay with that? What you are going to do? What is your solution? Yes? Lowering water table. Is it possible? Is it possible to drain all the water? There is a well. Can you drain all the water in the well? You can do it for certain process. You take up the water when you construct the outer wall. For all the foundation pit, if you are constructing the outer wall, the water will not come inside and you can drain all the water what is there, all the 4 sides and bottom. Everything you have to paste by the water or the concrete, then you can build the structure. But even though if you are doing that, what happens? There will be water from all the sides. Yes or no? From bottom, from all the sides. So there will be force by the water. What you are going to do? See, as a designer you have to think. That is what I first said, that designer need knowledge, experience and intuition, imagination. So what about your imagination? Think. What will be your solution? What you can do? Currently it is not constructed. It has been excavated. You should give the solution so that the laborers and men will work. The mason will always work. If you are giving 800 rupees, he will come and work. But he will not give the solution. He will directly construct. After construction, the person who is living there is going to take the consequences. Yes or no? As an engineer, you have to give the solution. So these are the points where you have the proportioning, connection and the foundation. So here comes the soil engineer and he will give the water table level, what is the moisture content, what kind of foundation you can put, everything you have to discuss here. Okay. Next thing is more exact analysis. This part, computer programs, more exact load. So I was teaching E-tabs. You can go through E-tabs and this will be useful for computer based program. Every engineer should know manual calculation at this level and the computer calculation at this level. So you should know at least one software. In this modern era, at least learn one software, either StatPro or E-tabs, or you can go for Tekla. More exact loads, behavior of structure and elements, behavior of connection. So when making the preliminary analysis, here you will be doing the exact analysis, and after that evaluation and final design. So this is the last step. Here you need code, construction and erection criteria. So here comes the design. So what you are studying now is the part evaluation and final design. The design criteria comes here and at the 2 points. So these are the 2 points where you are facing the design criteria and construction codes. So with these you can do the design process. Soon after your final design, if everything comes under the limit. So what are the limit which I have discussed in last class? Limit state of safety, limit state of serviceability and other limit state. So when you are checking, if it is failing, what you have to do? You have to do for the first process. You have to redesign your structural connection and check for preliminary analysis, proportioning, and you have to come with the final design. If this design is well within the limit, then the process stops. If it is safe in all aspects, then only you have to stop the process. Next topic, advantage of structural steel structure. That is structural steel and structure. Why you have two word here is, see, there are number of steel which are not used for structural purpose. The stainless steel are there, but it will be not used for structural purpose, isn't it? So there are more wide variety of steel is available. Only the civil engineer will be using certain variation of steel only. That is why here it is indicated as structural steel structure. So whatever the steel which you are using for construction, what are their properties? How you can go with that, and what are the advantages? So you can take it down. In maximum of the cases, the steel will be taking the tensile force. When you are using reinforced cement concrete, where you are introducing the steel, either at the bottom of the beam or at the top of the beam, where it is primarily used. Bottom. The bottom is the place where you have tensile force, and in order to reduce the tensile force or take care of the tensile force, you will be using the steel. So the compression force will be taken by the concrete. You will be taking steel as the primary member for tensile force only. And what is the another advantage of steel is high strength to weight ratio. So steel might be 1 kg. Say for example, you will be using a steel for the column. For the total height of the column, say for example 6 kg of steel you are using per feet. So how many feet are here? If you are having 10 feet, so 10 into 6 will be 60 kg. For a column, you will be having 60 kg of the self weight. For a 3-story structure, if you are taking single column, what will be the load in an average will be acting in a column? Take an example for residential house. Conventional residential house, what will be the load taken by a single column? See, if you are doing workout, you might be 70 kg. Can you lift 70 kg? It is only rare, those who are in training, they can do that. So if you are 100 kg, can you lift 100 kg? In the sense, if you are under training, you can do that. Can you take 2 times of your load? If you are 100, can you lift 200? Only Guinness World Record holders and the extremists can do that. Can you take 3 times your load? Impossible. But steel is taking how much times his own load? 66.6. That is why Iron Man is the different person, yes or no? Why iron and steel is much more fascinated? Why? Because he takes 66 times his own load. So this is an important thing and a best quality which can be given by the material. So that is why high strength to weight ratio. It takes more weight towards its self weight. Okay, which means high strength per unit mass is achievable. Steel can be easily fabricated and produced massively. If you compare with concrete and if you compare with steel, you can fabricate easily and produce massively. So you can get more number of steel components by the workshops, and it is easily available in all the suppliers. Steel section can be produced off-site at shop floors and assembled on-site. If you are going for a concrete member, you need more structural connections and you need a prefabrication plant. But if you are going into steel structure, you have number of shops which are available and commercial products are much more available in variety, you can easily assemble on the site. This saves the time and increase the efficiency. So due to its availability, if you want to make a concrete structure, this is why I have given an example of prefabricated structure in the last class. So when you have the members which are already made, the concrete have a disadvantage of gaining the strength after 28 days. But if you are using the steel, soon after you construct, soon after you connect, it has the 100% strength. So this is the advantage of steel, and this saves time and increase efficiency. So you can do the overall construction process quicker. Structural steel is very flexible, and you have elongation of 29%, yes or no? So when you are doing a tensile test in UTM, in building material testing lab, you will be doing tensile test for steel, yes or no? So what is the elongation value which you got for mild steel? Within the 2 bar, and at certain load, breaking point, neck point will be there, and you will be studying that behavior. Around 25 to 35% you will be getting for all the mild steel. So the mild steel can elongate. If you have 10 centimeter of length of a steel, it can elongate up to 13 centimeter. It cannot elongate more than that. So you have high flexibility. Can you drag the concrete like that? Make a concrete member, make a column. Can you drag that kind of a flexibility? It is not possible. So that is why the steel is more flexible, and it is the advantage of the steel structure. Take an example. I will tell you one of the example is boiling steel plant. The steel has to be boiled with a container. So you should have a container. Within that container you have to boil the steel. It is not water, the steel. It will be around 1500 to 2000 degrees centigrade. So in which material you will build the container? Can you go for concrete? Not at all possible. Why? Because due to heat you will be having cracks, and after cracks the steel will be going between that, yes or no? So the steel is the only member which can elongate 25 to 30% of elongation is possible. So that is why it is the advantage of steel. And you can mold the steel into any shape without changing the property. This is the another advantage. Whatever shape you can make into curve, straight line, or a bend shape, everything you can make. The steel is a moldable property without changing their property. You can convert into steel sheet or run into wires as per the design. The structural steel is relatively cheap when compared to the other building material. Currently around 70 rupees you can have 1 kg of steel. So if you want a 1 meter cube of concrete, so what is the cost? Around 4500, which will be much costlier than that. Okay. Then you take down all the properties, reliability, industrial behavior. You can make a steel factory, and less construction in time. It is not time consuming when you compare with concrete. High strength and lightweight in nature. Uniformity. When you buy steel, you can buy it number of times, the quality will not change. But if you are making a concrete, can you 100% say that the concrete which you have casted in first batch is equal to second batch? Manually, if you are doing, it is not possible. It will vary according to the batch and according to the quality which you maintain. So when you compare with the steel, is it the same? 99% it is the same, yes or no? The same strength will be there for another steel. How many steel if you are purchasing, the property will not change, and it is very near. But if you are making a concrete, the property might change according to batch by batch. It has high elasticity, ductility, and warning before failure. This is what I said. Percentage of elongation is 25 to 30%. Addition of existing structure. If already 3 floors are being constructed, you need a mobile tower to construct. Which material you will go? Either you will go for concrete tower or steel tower. Everybody is doing steel tower, yes or no? you will be having a 3-story or 2-story structure. Above that, if you want to construct, it is easy to construct by using steel. You can straight away use a tower bolt. By using that bolt, you can make the connection and you can start your construction without any disturbance. But in concrete, it is not possible. You have to first drill, take down the previous bar. There are some repair and rehabilitation process and possible reuse. You can build your steel, and if the tower is not required there, you can uninstall. You can take all the same material and you can build at another place without any waste. And scrap value is high. Watertight and airtight construction. Structures like reservoir, oil pipes, gas pipes. See, they will be laying the gas pipes and oil pipes below the ground. If it is made in steel, it is 100% safety. Soon, if you get any defect, if any holes is there, you can weld it quickly. But if you have any crack in concrete, is it possible to heal it quickly? It is not at all possible. You need rehabilitation process. You have to take old material and it is a long process. But in steel, it is the easiest process. You can straight away weld it immediately. Since it is an alloy of iron, it is susceptible to corrosion. All the structural steel, you have to maintain them either by making precautions or by painting. So you have to do a constant painting, and it can deteriorate due to the environmental condition, and according to humidity is the key factor in steel structure. What happens if the humidity is very high, the water presence is very high, there is a chance of high corrosion. So you cannot build the steel structure in seashore. When you are constructing, even it might be a single floor. If you are going for steel construction, it will be corroded quickly. Or else in the cold places where you find the negative temperature, you cannot go for steel structure. Why? Because the expansion and contraction will be very much high. You cannot go for steel at higher temperatures or as well as the lowest temperature. Wherever you have a moderate temperature within 10 to 40 degree. So within this range, the steel structure performs the most efficient. If you are going beyond that, you should have a proper maintenance activity. And due to its high maintenance cost, there is a disadvantage. Even though you have quick construction, but the maintenance is a disadvantage. So extensive fireproofing cost. So when the parameter fireproofing is taken, what happens? Steel loses its property when the temperature increases. Soon if your temperature is 100 degree, 200 degree, what happens? The steel property keep on reducing. The concrete has an advantage there. When you have fire, it can take around 800 degrees centigrade of heat. It can withstand. But if your steel cannot withstand up to that centigrade with the same structural property, it reduces its property when the temperature is higher. And buckling is an issue for steel structure. So you would have gone through this. Buckling is a character. If you have a column member raising the height, what happens? If small load is acting, the column tends to buckle, that is, it tends to bend. So you would have gone through that Euler's buckling failure or Rankine's buckling failure. So in that, the buckling load will be taken. So if you are keep on increasing the height, what happens? The buckling will be there. The high expansion rate with change in temperature. Okay. See, this is a statistics. The steel loses 1 to 1.5 mm of their thickness each year. If you are having a section of 10 mm, what happens? After 1 year, the section will become 9 mm. It reduces its thickness. If you are going for the third year, it reduces further to 8 mm. So this is a statistics. The steel always is supposed to the environmental aspect. So it has the environmental issues it deteriorates with that. So around 1 to 1.5 times the thickness will be reduced, unless or otherwise if you take care of that. That is painting. If you have done that and if you have stopped the corrosion, it will not have the same deterioration. If you simply left the steel without any maintenance, soon after 10 years the steel member will not be there and it can lose the weight up to 35%. If the steel is 5 kg, it will be reduced to 3 kg. Yes or no? What happens? Your strength automatically gets reduced. And fireproofing cost at about 400 degrees centigrade, creep becomes more pronounced. So creep is a important parameter which you will learn in your higher studies. Susceptibility to buckling, higher initial cost. If you want steel structure, high cost you should invest, and aesthetics. So these are the disadvantages. So you cannot expect a more aesthetic structure in steel. Yes or no? If you are building a workshop, can you make number of aesthetic views and appearance? In steel it is not possible. That is why they are laying the panels, exterior facets and panels. So without that panels, the steel is very awkward. So as well as the concrete, if you compare, the aesthetic is very much less. See, in IS 800, in previous versions you can find working stress method of design. Now it is limit state design. Okay, what is limit state in the sense? You want to make a construction. So you derive what will be your property and what is your expectation for your construction. First you write that. When you are writing that, what will be the first and foremost requirement for a construction? If you are building your own house, what are the requirements? You list it down one by one. What is your primary requirement? Your building or your house should not collapse. You imagine yourself and you write all the points. Will you allow your structure to collapse? Will you allow your building to collapse? No, you will not allow. So that is the first point. Limit state of collapse. Okay, now how to safeguard your structure before collapse? How you can do that? Think. Your structure should not collapse. So what you should do? You should find the capacity of the material. What is M20? If you are making M25 grade concrete, it can take 25 Newton per mm square of stress. So this is the stress carrying capacity. Okay. Now in limit state you are saying, if you want to build your structure, my structure is going to take all these loads. So what are the loads which will be acting in your structure? You list it out one by one. What are the loads? Dead weight, that is the self weight of the load. Then live load. The live loads can be the table, chair and the humans. All the things comes under the live load. You have to consider live load. Then do you expect your house to face a severe wind blow? So you should look into your code books, and the code books suggest that 40 meter per second, up to 40 meter per second, you can assume that as the wind force. And do you have seismic zone? Yes or no? The India has been classified into different seismic zone. What is the seismic zone? Bangalore. Zone 2. And the Bhuj. Bhuj is a place where you have in Gujarat. So in Gujarat you have a place called Bhuj. What is the zone of that area? Zone 5. That is why before 10 or 15 years you had an earthquake there. Yes or no? That is the severe zone. Hence they are indicating it by severity as 5. Bangalore is a safe zone. It comes under zone 2. If you want to build your house, we will ask that where is your place? Where is your location? Are you building in Chanpatna? Are you building in Ramnagara? You should check that. You have the zone for your district. Check your zone. And you should take the zone and you will be taking how many loads? Dead load, live load, wind load, earthquake load. So these are the 4 loads you should take care, and then you will start constructing. So this is what the limit state says, that if you are taking all the loads, can you find stress? Okay. The rest of the things I will continue in next class.